So let us look at 2014 number 1. So in this question, grace clippings are placed in a bin where they decompose. So we have the t goes from 0 to 30, and then A is the amount of the grass clippings in the bin. T is the measure in days. So first find the average rate. So in order for us to do this one, I'm going to put this one into my calculator. So you can put the function a sub t into your calculator as well. So in my case, what I'm going to do is I'm going to set y equals y sub 1 equals to a sub t. So I'm going to do 6.687 times 0.931 to the t power. So I'm just going to call it as x. All right. So now for the first one, what we want to do is we want to find the average rate. So in that case, we are looking at a of 30 minus a of 0 over 30 minus 0 would have been our average rate of change. All right, so what I'm going to do is alpha y equals, I'm going to make a fraction. So trace, open 30, so y sub 30 minus y sub 0. So I'm plugging in 30 and 0, and then 30 minus 0 is simply 30. So when I do that, I get negative 0.1968. So we get negative 0.197. Rounded, it'll be pounds per day. All right, so that would be the average rate of change. Find the value of A prime of 15, and B, using the calculator, A prime of 15. So what I'm going to do is math, and div number 8, x, y sub 1. And when x value is equal to 15, so negative 0.164, I guess rounding, negative 0.164. But the correct unit would be, I guess, pounds per day. Now, and then it's simply saying when t equals 15, the amount of clippings is decreasing at a rate of 0.164 pounds per day. That's basically what we can write. Let's look at part C. Find time t for which the amount of grass clipping in the bin is equal to the average amount. So then in this case, what we're looking at is number C, a sub t. I'm looking for that time t when that's equal to 130, because average value is integral from 0 to 30 of a of t dt. So what I'm going to do is I'm gonna go for y equals, and then on the y sub 2, I'm gonna put that in 1 over 30, and then I'm gonna get the integral, which is number 9, from 0 through 30, and then that's y sub 1. Oops. Y sub 1. And then dx. So by having these two equations, I'm setting them up. I'm graphing both equations. I'm planning to look for the intersection. So window will be 0 through 30 because 0 through 30, yeah, those are the values. And I'm gonna go for zoom fit. Oops. And then zoom fit 0. As you can see, they are meeting up together. Now then, second calc, intersect number 5, bam bam. All right, it's 12.414 or 415. So here t is equal to 12.415 day. Right, that's basically what we end up getting. Let's look at part D. Part D is we need to figure out the linear approximation when t is equal to 0. T is equal to 30. So then linear approximation L of t is in fact equal to a sub 30 and then plus a prime of 30 and t minus 30. That's basically what we end up getting. I just rewrote this one to y minus y sub 1, and then I just moved it over, plus m times x minus x sub 1. That's essentially what we're looking at. Now, we want to see what the value would have been, but this one has to be equal to it, 0.5. So what I'm going to do is I'm going to put this one in y sub 2. So I'm going to rewrite because I don't need that anymore. Or I can maybe just hold on to that, just unhighlighted. Y sub 3 is the linear approximation. So I'm going to put y sub 1, parentheses 30, plus, and I'm going to take the derivative, math derivative number 8, y sub 1, when x equals 30, and then we're going to multiply that by x minus 30. Now, I'm going to unhighlight this one so that I don't have to see it. But that has to be equal to 0.5. The linear approximation has to be equal to 0.5. And then the question says t was greater than 30, so I'm going to set the window. Starting from 30, maybe I'm just going to go for 40. How about that? And then I'm going to go for zoom fit, which is number 0. That's the linear approximation, and then 0.5. So we see the intersection over there. So what I'm going to do is second trace, intersect, bam, 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 35.054. So we get t equals 35.054. We set L of t is equal to 0.5, and that's basically what happened. All right, with that one, I'm going to close up. I'll see you later.